Hi everyone, welcome back for another lesson for Algebra 1. We're still in units, like the combined Unit 1 and 2, expressions and equations, and we're actually still focusing on expressions today. Today we're going to be focusing on combining like terms and the distributive property. Again, this is a topic that you guys have seen before, so we're going to kind of breeze through this pretty quickly. It's going to be pretty quick notes for you today. If at any time we're going too fast or you want to review something, please pause the video and rewind. And yeah, let's go ahead and get started. Alright, simplifying algebraic expressions. Last time we talked algebraic expressions, we went over they are expressions that have variables in them, okay? And simplify means to try to get it as close to one variable as possible. Now, with algebraic expressions with variables, if we don't know the value of it, we can't perform the operations on that number, okay? So with algebraic expressions, we actually, most of the time, will not actually get a single number for our answer. We might get a smaller expression, okay? So, and there's two steps on how to just simplify an algebraic expression. Step one is to do any distributing that is there. Okay, and we'll talk about what that looks like in an expression, but you always want to take care of the distributing first. Step two is to combine like terms. Okay, like terms are the things that we actually could simplify. Okay, so let's go ahead and talk about what like terms are and what they look like, what they don't look like, and how to combine them first. Okay, so combining like terms. What are terms? We talked about this last class. Terms are part of an expression separated by addition signs. Oh, let's see if I can click on it. There we go. Addition signs. Only addition signs. Last class I mentioned addition signs are going to be your big thing. Subtraction signs can separate terms, but they're also part of the term. So really a subtraction sign is just plus that negative term behind it. Okay? And I'll show you what this looks like. But basically any subtraction sign is really plus a negative. Okay? And I'll show you what this looks like. So here we have one term. Negative 4xy is one single term. Clicky, click, click, click. There we go. One term. Okay? There's only one thing. There's no addition or subtraction with anything else. Okay? Here we have x squared and negative 6, x squared minus 16. That is actually two separate terms, okay? So there's two parts. X squared is one term. Negative 16 here is another term. Not just 16, it's negative 16, okay? Because I could rewrite this to be x squared plus negative 16. In fact, I'll do that underneath. X, oh no! Edit, undo. Edit, undo. Oh! Alright, so see, crazy things happen in notes, just like a normal class. Let's go. What just happened? Okay, nothing happened. Cool. Sorry. Little malfunction. That's okay. Just makes life interesting. Alright, so one term here, and two terms here. So we actually have x squared minus 16 is two terms, where the two terms are x squared and negative 16. Here, you can probably figure it out. We have three terms. We have negative 4y, positive 6x, and this minus sign can be written as plus negative xy. So negative xy is our third term. Okay? Three terms here. There's a little 3 hanging out. Okay? Alright. Go ahead. This next part, you're going to do... Oh. I was very nice to you on this. I was very nice to you on this because I wasn't paying attention. You're supposed to do this on your own, but I've kind of done it for you. Okay? You got... It's asking you how many terms. Good rule of thumb when you're counting terms, and when we talk about combining like terms, is to separate them out visually. Okay? So clearly I've done it. Take a few minutes, pause the video, write down how many terms are in the thing. This should be really fast. And by pause, you're going to like click, click. And yeah. I'll have them ready for you when you get back. Go ahead and pause. Okay, you're back. So let's go through these answers. There were some, yeah. Okay, here, two separate terms. These are each separated by an addition sign. So here we have two terms. Here, only one term was here. And here we actually had three separate terms where it's y squared, 2y, and negative 15. So those are three terms. I know, that was really hard. Alright, last little bit. You can kind of see. What are like terms? This is the last bit for this page at least. What are like terms? Like terms are going to have the same variables, okay? And they're also going to have the same exponents on those variables. So remember, these are the exponents right here, these little floating numbers, okay? So they have to have the same, basically their variable part needs to look exactly the same. Their coefficient can be different, but the variable part has to look identical. So if you look up here, like, if this negative xy was going to have a like term, it would also have to have that x and y part, okay? So let's go ahead and look at some examples of like terms. Alright, here's a little chart. Examples of like terms and not like terms. So here, x and 4x are the same. They have the same variable, and their x variable has the same exponent of nothing. They don't have an exponent. Okay? 18 and negative 22 are like terms. You guys already combine them all the time. They're the same thing. They're both numbers. They don't have variables. So because they both don't have a variable, you can combine them. Or they're the same. They're like terms. 9ab and negative ab are like terms because they both have the ab part. Their variables are exactly the same. Their exponents of no exponents are exactly the same. The only difference is this has a 9 as a coefficient, where the coefficient here, hopefully you guys know, this is actually a negative 1 as a coefficient. You're going to see a lot of invisible ones throughout algebra, okay? So anytime you see a negative, it's really like a -1 being multiplied with that number behind it, okay? Negative 22, this is going to, anytime you see a negative in front of a variable, it's really like a -1 or a -1 being multiplied with that variable, okay? Not like terms would be things that maybe they share the same variable, but they don't have the same exponent. So this one doesn't have an exponent, this one has an exponent of 2, okay? Here, maybe they have the same variable and the same coefficient, but not everything matches, okay? Just because they have the same coefficient does not mean they are like terms. Again, same variables, but different exponents, so they're not the same, okay? Now, this part looks like fun. Go ahead and take a few minutes to do this on your own. You got about 25 in here and 5 different circles. So go ahead and match up the like terms. So everything in the box here belongs in one of these 5 circles. Go match it with its like term, okay? Go ahead and hit pause, and I'll have the answers ready for you when you get back. Okay, so this is going to take me a while to get all the answers because there's a bunch. I feel like there's one more here. Yeah. Those are all your like terms with 3. They all are constants, okay? Down here with 4a, we got 18a, 2a, 3a, 10a, and 43a. They all have the same variable of a and no exponent. Okay, 9a squared. We've got 4a squared, 5a squared, a squared, and 6a squared. They all have the a squared part. Okay, 7ab, we got 43ab, 5ab, ab itself, that has a coefficient of 1. 16ab and 11ab, they all have that ab. And 2ab squared would be ab squared, again, a coefficient of 1 there. 5ab squared, 10ab squared, 53ab squared, and 2ab squared. They all have that same variable part, the ab squared. Okay? Notice how none of them have the A part, like 4A in here, because they don't have the exact same thing. Okay? Not too bad. Moving on. Now, how do we combine like terms? Once we figure out what the like terms are, how are we going to combine? Well, what does combine mean? It means to put together. Mathematically, how do we put two numbers together? We add them, okay? We add the coefficients together because the like terms already have the same variables. The only difference that they might have is their coefficients. So we add those numbers together, okay? So, examples. Here we go. A. 2A plus 3A. So this is what I want you to get in the habit of doing. I want you to box your like terms together. Use symbols to show each other, like just separate out your like terms so you know which one's which. So here, 2A, where's my box? 2A and 3A are like terms. So I go ahead and I combine their coefficients. 2 plus 3 gives me 5. So my answer would be 5A. Okay? B, I got 5A, or 5N and a single N. Okay? To combine those, they're the same variable, so I add the coefficients. Here the coefficient is 5. The second one, it's got an invisible 1 here. The coefficient is 1. So 5 plus 1 gives me 6. So in total, I have 6A. Okay? 6A squared, a single A squared, and remember, what is this? It's not a minus 9, it's a plus a negative 9. So negative 9x squared is another like term. Okay? So I go ahead and combine all those coefficients, the 6, this invisible 1, and the negative 9. I get negative 2. That becomes my new coefficient. Negative 2x squared. Okay? Now, these are a little bit more tricky because you have to do, A, you have to do them on your own, and B, they also have multiple variables in here. Okay? So here, we box the ones that were the same, use other shapes like stars, squiggles, underline. Okay? So you might have boxes and circles in one expression to show the different like terms, and you combine the like terms together. Okay, so go ahead and pause this video, try these two problems on your own. And when we come back, we'll go through the answer. Okay? Good luck. Alright, so we're back. Here is the answer to the first one. You had to combine the 3x and the negative 6x with each other. And then you had to combine the negative 2y and the positive 8y together. And all together, you should get negative 3x plus 6y. Okay? The second one, you had to combine the 3x and the negative 15x. And then the negative 9 here, that actually doesn't have any other like terms. So that would just be left alone and you'd keep the negative 9 in there. So your answer would be negative 12x minus 9. Okay? So that's all there is on combining like terms. Let's go back to that first step about distributive property. Again, it's something you guys have seen before, so it's nothing to worry about. So the distributive property is multiplication that's been distributed. It's been like passed out over, I don't know why this came out like this. There you go. Distributive property is multiplication distributed over either addition or subtraction. Okay? And here's a big chart to remind yourselves. There you go. So the product of A and B plus C, so it's always going to be like a number times a group. Okay? That number hanging out on the outside gets multiplied with both parts, or all three parts, or however big the group is, all the parts of that group. So this A gets multiplied with the B and that positive C. Okay? And it could be on either the front or the back end. It also works with the minus sign. Okay? The subtraction. So A gets multiplied with the B. Remember, this minus sign is really plus a negative C. So that A gets multiplied by a negative C. Okay? So like here, for real numbers, 4 got multiplied with the X, giving you 4X. 4 gets multiplied with the negative 7. We get negative 28. Okay? Alright. Let's go on to the last page. Our examples for this, okay? So I've got an 8 hanging out on the front, on the end here. So I actually need to distribute that 8 to both the 1 and the 2n. So now it looks like this. 1 times 8 plus 2n times 8. And now I just go ahead and simplify this because I can do this multiplication. 1 times 8 is easy. 2n times 8, whenever you do multiplication, you always multiply the coefficients and then just keep all the variables in it as well. So 1 times 8 gives me 8. 2n times 8, 2 times 8 gives me 16. Only one variable of n, so 16n. Okay? This next one's a little bit tougher. I've got more stuff hanging out. So here, this says negative x minus 3x plus x squared. Okay? So really, this minus sign, I'm going to go ahead and change to a plus sign. Okay? So that means it's going to become negative x plus that negative, and remember, it's an invisible 1. So plus negative 1 times 3x plus x squared. Okay? So that means this negative 1 is the thing that's getting multiplied by the group. So negative 1 must be distributed to the x squared as well as to the 3x. So I go ahead and do that. So now I have negative x, that's still hanging out up front, plus negative 1 times 3x plus negative 1 times x squared. I can do this multiplication. Ooh, I just gave something away. Negative x plus negative 3x plus negative x squared. Now I'm going to go ahead and combine my like terms. Okay, I've got a negative x and I have a negative 3x. And then I just have a single negative x squared. So I'm going to combine my like terms here. Negative 1 plus negative 3 gives me negative 4x. Ooh, I definitely did something wrong with this one. What should this be? What do you think it should be? Won't let me fix it. Oh, maybe I did. I got in there. Nah, it won't let me fix it. I accidentally put a 4 in here for some reason. So that should not be there. Let's go ahead and just delete that. Okay, let's do something else. So we got negative 4x plus negative x, what is it, squared? Yeah, squared. You're going to get all of my fancy tricks. Something just happened. Yeah. Something weird. Oh, sorry if I'm taking too long. Anyway, so I'm only combining my like terms here, right? Let's type something first, and then we'll change it. Haha! Fun day today with notes. But I'm not done, okay? Last little bit is more like a grammar thing. It's not like I'm going to mark you off, but I will give you feedback on it if it happens, okay? It's bad grammar in math to have two signs following each other. So I have a plus sign and a negative sign here. That's not really good math. So what happens is they like to simplify this. A positive and a negative make a negative. Okay, so you just change that to one big negative sign, which means it's a subtraction sign. Okay, where if it was like two negatives, like a minus sign and then a negative, that makes a positive sign. So really my final answer would be, without this 4, rawr. Wrong, 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 wrong. Oh, goodness. Life is so hard. I would just chop off this plus sign and keep it as minus x squared. That'd be my final answer. Okay? Alright, sorry that took so long. Last little bit for you is 3 problems here. Try on your own. These first 2 should be really easy. This one is a bit longer. Okay, you got 2 things you got to distribute over 3 parts. Okay, here you're distributing the 2, the negative 2, the negative 5q, and so on. What do you think you're distributing here? Okay, change that subtraction sign. Think about that one, alright? Go ahead and pause the video, and when you come back, I'll have the answers, and then we're done. Okay? Bye! Alright, so we're back. So this first one, you had to distribute the 1/2 to the 2x and to that -4, giving you an answer of x minus 2. Here, this negative sign is really a -1. So you're distributing out a -1 to everything, giving you an answer of -6 plus 3x. Finally, this long one, you had to distribute the 2. Okay? So this one had a lot of parts. You had to distribute twice and combine. Okay? So you had to distribute this 2 out to the -2, the -5q, and the positive x. And then this became a plus a -1, right? So you had to distribute out the -1 to the 3q, to the y, and to the -3. Once you have that big long expression, then you can combine like terms, and your final answer should have been 15 minus 13q minus y. Now remember, if at any point you had trouble with this, please make a note of it and make sure you ask me in class, okay? Other than that, I'm done. You guys have a great night. Thanks. You've been an amazing audience. Don't forget to like and subscribe, and I will see you in class. Bye!